Right, so let's come back to problem number 2 where we're going to finish this off. So it looks like that we're going to be solving out for FGY and FGX. Okay, so what I'm just going to do here is this. Let's just redraw our triangle down here. So I'm just going to redraw this. Being that we do have all of this room, I want to utilize it. And we have our FG over here, which is 562 newtons. And we have our FGY and FGX. So we want to find out what FGY and FGX are equal to. That's what the problem is telling us. So for us to do that, being that we do have this one side and an angle, we could use trigonometry. Hey, you know what? So what's the first step into doing this if we're going to be using trigonometry? Well, we have to identify the different parts of the triangle. Hypotenuse, opposite, adjacent. You remember that? So this 562 represents what? Hopefully you're saying to yourself the idea that it represents the hypotenuse. And what does this FGX represent? Well, it's the part of the triangle that's all the way over here, right? And that's the farthest away from the reference angle. So therefore, that must be the opposite side. And this part of the triangle over here, which is right next to the reference angle or touching the reference angle, is our adjacent side. Okay, so we have our triangle identified, and now the next thing that we want to do is try to figure out which trig function we want to use. If you haven't been taught trigonometry yet, go back to my vectors unit where I explain how to solve for the triangles using trigonometry. Okay, so which one of these do we want to solve for first? It doesn't really matter, but we do know that we have this over here, which is our hypotenuse, and say if we want to find out what the opposite is first, our FGX. So therefore, we're dealing with our opposite and our hypotenuse. Which one of these trig functions do we want to use? Which one has to do with opposite and hypotenuse? Hopefully you're saying to yourself, the sine function. Okay, so that being the case, let's do that. So sine of the reference angle, which is 30 degrees, is equal to the opposite, which is FGX, divided by the hypotenuse, which is 562. All we have to do is multiply 562 to both sides of the equation, and we have 562 times the sine of 30 degrees, not 562 times 30 and take the sine of that. It's 562 times the sine of 30 degrees, and we'll get our answer. So we have 281 newtons is equal to FGX. And the next part is to find out what FGY is equal to. Keeping in mind the idea that once again we do have our hypotenuse and FGY is our adjacent. Which one of these trig functions are we going to be using here? So hopefully you're saying to yourself the cosine function. So cosine of 30 degrees is equal to our adjacent over our hypotenuse. Once again, we multiply 562 to both sides of the equation. So 562 times the cosine of 30 degrees will give us our answer. And we have 487 newtons. Let's see if those were correct. Yeah, we have 281 and 487. Those two look correct. All right, and that's the rest of this problem. So, last thing I do want to mention though is the idea that being that this is going down, and we see that it's going down like this, and our positive direction is going up in this angle like this, would we want to make this a negative 487? And the answer to that is no. No, we wouldn't. Because if we're to actually use this, we have FGY over here. If we were to plug this into this calculation over here, this negative here already represents the direction. And if we were to make this negative and this negative, then we would be accounting for the direction twice, which is something that we don't want to do.